Alright, let's continue our discussion on chain rule. Yesterday we talked about chain rule. Today we're going to take that chain rule and go a lot further with it. So let's see here. First question says, we want to find the second derivative of this function at 4 times x squared minus 5 cubed. Now remember, we have to do the derivative 2 times. So the first time when we take the derivative, we would get f prime of x. Remember, this is chain rule. We have this little inside part here, and we have this outside part. So chain rule, you might remember, to do chain rule, it's the derivative of the outside multiplied by the derivative of the inside. So when we take that outside derivative, we're going to drop that 3 down, and that's going to give us 12 times x squared minus 5 squared times, now we take the derivative of the inside, 2x. Okay, there's my first derivative. Now I do have to take a second derivative. So to make this look a little bit nicer, I am going to clean this up. So my first derivative becomes 24x times x squared minus 5 squared. Now we're ready to take the second derivative. But if you notice, we have 2 variables here, 2 terms with an x. So this is going to be our product rule. Now we do have a chain rule here again, but product rule is our big picture. So taking the second derivative, that's why we put that double prime there. We're going to take our first function, which is this 24x, and multiply that by the derivative of our second function. Now, for our second function, we have this inside part and this outside part. Taking the derivative of the outside, we're going to get 2 times x squared minus 5 times, then we do the derivative of the inside, 2x. That's the first part of our product rule, plus, now we're going to take the second function, x squared minus 5 squared, multiply that by the derivative of the first function, and that just becomes 24. This is very ugly, but we're done. Remember, we don't have to simplify if we don't want to. If you do, you will get an answer. I mean, you can multiply the 2 times 2, which is 4. You would get 96x squared times x squared minus 5 plus 24x squared minus 5 squared. And there's our answer. Remember, there's a lot of rules for chain rule. We just want to be able to take the derivative. A lot of times what I'll see students do is there's a rule for it, okay? If they see something like, let's just do the first derivative, x squared minus 5 cubed, they'll take this. They'll take the derivative of the outside, and a lot of books teach it this way. I'm not a big fan of it, times the derivative of x squared dx. Now this is basically what chain rule is saying. Derivative of the outside, derivative of my inside function. Whoops, we got my minus 5 there though. And then they'll say, okay, it's just an extra step, so they'll go 12x squared minus 5 times 2x. We get the same answer. All right, there it is. We get the same answer, but it takes an extra step for us. So you want to just be able to do it in your head. That's the whole goal. I mean, of all things to do in your head, this is what you want to be able to do. All right, here's the hardest one there is. This is the hardest question you will get. Find the points where a function has a horizontal tangent. Couple things here. One, we're looking for the slope is equal to 0, and we need x and y. The y value is the part that comes at the end. So we know we're going to have to take the derivative. I don't like that radical there at the bottom, so I rewrite this as 2x minus 1 to the 1/2. This is our quotient rule. Our big picture, that's quotient rule. So when we take the derivative, quotient rule says low d high minus, now watch what I'm going to do here. From experience, this is what I know. Ready? High d low. When I take the derivative at the bottom, I'm going to get this 1/2. That's going to put this 2 on the bottom. And that's going to give me a negative 1/2 power here. So that becomes 2x minus 1 to the 1/2, but on bottom. Remember, you want to start doing this in your head. And I'm going to multiply that by the derivative of the inside. And that goes on top, which is just 2x. All over the bottom squared, which is just 2 over 2. If you put that as a 1, that's fine. Whatever. Okay, now I'm not done yet because remember we don't like this complex fraction here, so I multiply top and bottom by my common denominator. Both top and bottom. Don't forget that. And when we simplify this, when we distribute on top, we're going to get 2. Now I have 2x to the 1/2 times 2x to the 1/2. That just becomes 2x to the 1 to the first power. Minus, distribute here, the whole denominator cancels, and that just becomes 2x. The bottom becomes 2. Now, there's a reason I don't simplify here yet, because when I take this 2x minus 2 to the 2/2 times 2x minus 1 to the 1/2, that gives me 2x minus 1 to the 3/2. And there's our answer for now. Okay? Now, we're not done yet because we do have to set this equal to 0. Now, you might recall from our lesson yesterday, if I set equal to 0, I really don't care about the denominator here. We don't need that. But I do need to set the top equal to 0. 2 times 2x minus 1 minus 2x. Solve that, of course. We get 0 equals 4x minus 2x, or should have gone faster with this one. 0 equals 2x minus 2. X, of course, equals 1. You might recall yesterday I said because I have to apply this, I simplified it. Now you know why I simplified it. It makes this a lot easier step to do that if I would have done that. So we got x equals 1, and now we have to find the point. If x equals 1, we have to find y. Don't forget, we're going to use the original function itself. So f of 1, 1 over the square root of 2 times 1 minus 1, which is just 1. So the point is 1, 1. This is going to be on a test. This is going to be on a quiz. A question like this is like 8 points, okay? This is the hardest part. Now take a look. Now yesterday we did the same step right here in 3 steps. Now we can do it in 1 or 2 steps. We want to shorten it down. So try this a lot of times. How many times is a lot? A lot. 5, 6 times until you get to the pattern of it. It's really not that bad to do. Alright, this is not that bad to do. Find g prime of x, given g of x is this. This is a composite function. Notice we have an outside, which is f of x, and we have this inside function. Again, this is kind of like our analytic limits, derivatives from yesterday. So if I want to find g prime of x, I'm going to take the derivative of the outside, which is going to be f prime 2x cubed, multiply that by the derivative of the inside, 6x. If you do this right, you will be 6x-ful. Get it? 6x. Okay. They're not any better live either, I promise. Alright, so there we have our quick review of chain rule. Go to part 2 and we'll take a look at a few more examples on the back.